Hello everybody, and good evening. Good, how do I say? Hello everybody, and good evening, and from Sarawak, from Borneo. So today, we can go and start live right now. So let's go. All right. Hello everybody, and good evening from me. I'm Dino Suguwa, your host today for the launch of the Falcon 9 Block 5 rocket that will carry the Starlink 7, I believe, yeah, 10-46. Yeah, correct. It should be 10-46. So why not? Um, and we have already start the stream. So why not? Let's go directly here. All right. So as you can see, this is the advertisement already start for the um, how do I say? It's already start the stream right now, and for your information, I need to tell you that thank you very much to Space Affairs for restream this live stream from SpaceX, because otherwise, sorry, because otherwise we might not be able to stream this according to the time. So that's why it's very important. So that's why. And also, what I need to tell you that for this mission, this Starlink Group 10-46, there is 29 satellites that will be launched on board into the 56-degree orbit inclination, targeting 279 kilometers. And each of these Starlink weights around totally massed around 525 kilograms, if I'm not mistaken. That's also including with the total on propellant on board and whatnot. RCS, just to bring that Starlink upward for sure. And of course, forgot to tell you, as you can see in the visual view right now, here you can see half of the fairing has already been used multiple times. Another half is like less relatively less used and looks a little bit lesser, how do I say, lesser better in comparison to how do I say, less charred in comparison to the other left side. So to the other side, so you can see that's why it's even okay. So I guess I can close this music now. You guys can hear this. Okay. So you can hear the telemetry, the call out and whatnot. And of course, in this Starlink, especially for the Starlink launches, if you actually notice, excuse me, if you actually notice that most of it now prominently going in for the, how do I say, now mostly going with the route of advertising. As you can see, one part about it, about the coffee farmer in Brazil, yeah, in Brazil actually were advertised that it works because, yeah, remote location and whatnot. So Starlink does serve for this kind of customer as well. And of course, we are going to go back to what I want to say about the Starlink is that this current Starlink is the Starlink version 2 mini. Yeah, it's not a big in comparison to the version 3 one. And as you can see, the real you can see right now it's already have more than 10,000 satellites operational in the orbit, especially after the launch of the um, Starlink 17-24. Yeah, I suppose supposedly I should have streamed around few hours ago, but what happened is that there is a slight technical difficulties last minute that I cannot resolve right on time. So that's why I have to I have to delete. How do I say? I have to bring the stream originally intended for the Vandenberg launches one. This one is the Cap Canaveral launches. I have to bring it somewhere around another day. Could from my schedule, it would be around 25 March, if I remember correctly. Yeah, it should be around 25 March, which would be on on Wednesday, 25 March 2026. So yeah, that one fortunately something I can do with minor shuffling. Yeah, so and also I target this Starlink launches. At least there's like two pairs of these launches from one from Vandenberg and another one from Cape Canaveral uh, on each month. I'll do it to keep this channel periodically update, you know. And also maybe I will also going to show you the launches from
Okay,
the
one
Vandenberg.
minute is complete.
Okay, stage two, liquid oxygen has already completed um, in terms of fueling, so that's also good. And also, I need to tell you that each time of the advertising, sometimes it can also shows different things and whatnot. So that's why I intend to go live previously, but well, such a life, isn't it? Okay, and also for the start.
Cutoff.
Oh, okay. So almost ready for the computer onboard startup on the Falcon 9 rockets there. That one, when it start up, it will go into the autonomous mode where the computers will start taking over everything else, whatever needed for the from pre-launch on T-1 minute mark here, 60 seconds,
Falcon
uh,
9's in startup.
up until the orbital insertion followed by another orbital raising maneuver, and then after that Starlink deployment. And also okay, so launch director has already been given go for this launch to proceed. This one is from the we are looking at the Cape Canaveral Space Force
T minus 30
Station
seconds.
on the Space Launch Complex 40, or aka known as the Slick 40. So here we go. We are also going to see the landing of the booster itself. So that's going to be very good.
T minus 15 seconds.
And about the Starlink, yeah, of course, it has two solar panels.
10,
10, 9,
9, 8,
8,
7,
7,
6,
6, 5,
5,
4,
4,
3,
3,
2,
2,
1,
1.
0.
Ignition.
Ignition of all
And
9
let's
Merlin
go.
1D
Go Falcon.
engine on
Start.
the first stage booster, and liftoff from the Cape Canaveral Space Force Station from the Slick
Vehicle
40,
switching downrange.
launching the Falcon 9 Block 5 rocket carrying Starlink Group 7 Starlink 10-46. So yeah, correction there. And you can see on the launches, it looks pretty good there, looking pretty majestic on the flight. All right, so it's already passing through the cloud, and of course, it's already going into the subsonic speed there, Mach zero point 0.5. At this point, the Merlin 1D engine has already been throttled
Yeah,
down to
between nominal.
60%, or could be slightly little bit uh, more
Vehicle
before.
supersonic.
Okay, it's already reaching supersonic, and afterward we'll hear the call out of the max Q, peak maximum aerodynamic pressure, with the peak mechanical stress incur on the rocket itself. Let's listen in.
Max Q.
All right, so we have already listened in. Max Q has already been confirmed. Maximum aerodynamic pressure. He- And after the max Q, usually the Merlin 1D engine, or usually any typical rocket engines, will going up back to 100%, but sometimes it also can just throttle up straight up, probably just 80%
Call
instead.
back click.
Okay, so we hear the call out of the MVAC chill, which means that the Merlin vacuum engine on the second stage has already been being started in terms of cooling. So by the time the engine ignited, it's not going to cause any temperature shock there, or possibly causing any kinds of rocket engines melting there. So that's why it's pretty important to chill down the rocket engine even before the flight, and also even before. the ignition of the second stage. And as you can see, as it travels into the atmosphere, by now it should have mm, already gone more than Mach 4. By now it's already reaching hypersonic, and we're listening to the Miko main engine cutoff. All right,
Main engine cutoff.
main engine cutoff confirmed,
Stage separation
and
confirmed.
stage separation has already confirmed from the visual and also telemetry. And here
And
we
now
go,
start.
pre-start, and we have ignition of the Merlin vacuum engine on the second stage. And as you can see, if you actually notice, the second stage engine is essentially identical to the first stage engine, but it's actually designed with with bigger and also longer nozzle extension. Why is that?
Air
Why is that very
circulation
important?
confirmed.
All right, so we've heard the call out of the fairing separation there. Okay, so I can go first with the why the engine nozzle, when it's designed for space environment, it has to be very long and also big, because when you're in space, when you try to burn something, especially the rocket exhaust, it can when it usually exit the end of the nozzle, usually it will extend, the flame will actually extend infinitely bigger and bigger. Just mostly what will limits is how big is that flame. Okay, and this kind of flame, because it's not no longer being held by the atmospheric pressure, and also by the atmospheric layer and what's on. That's why most of the efficiency mostly being thrown out in terms of this kind of flame. And in order to prevent in order to prevent like 80% of thrust efficiency lost there, usually they will extend the rocket bell nozzle there to ensure that they can capture most of the thrust, and also at the same time uh, to make the rocket engine operates at very optimal, and also at its maximum performance as much as possible. And as for the red hot glow there, this one actually it's because Falcon 9 rocket, all of the rocket stages were actually burned hydrocarbon elements there. So when I said the hydrocarbon element, do you actually know that uh, the Falcon 9 actually burns Carolox propellant. So Carolox propellant, this one is actually a combination word between kerosene and liquid oxygen, which liquid oxygen were shortened into the LOX. That's why you hear that call. And when you combine it together, it become a Carolox. And when these two burns together, of course, because it only has carbon and hydrogen with the long chain complicated, however I want to say, too much too much complicated physics and chemistry there, but it's basically very complicated chain of hydrocarbon. When it burns together, of course, it's going to produce tons of soot, uh, plenty of heats and whatnot. So that's why you see it's glowing red hot there. And we are going to hear the call out of the entry burn on the first
Stage
stage.
1 FTS has ceased.
Okay, FTS
Awaiting
stands for
entry burn startup.
flight termination system. It's no longer have to be used on the first stage. And you can see the first one of the 9 Merlin engine first ignite, followed by another two set there on the left and right side there. And now it's this entry burn is actually pretty important to slow down the first stage booster in order to ensure that it's not going to damage the first stage booster, and also to ensure that all is good, you know, to ensure it's not going to get all of that heat. And of course, most of the flame will rocket flame, and also the velocity reduction will be absorbed by it. So that's why. And yeah, you heard tens of seconds ago of the entry burn ended call out there. Yeah. And also for the firing part of the side, even though we are not where even though we didn't see where it's going, but definitely for sure, just like I showed you in the earlier shot, just like I explained to you earlier on, before the mission start. The first stage, how do I say? Sorry, the fairing um, how do I say, the fairing shroud payload itself is actually, the function is pretty simple to protect the payload inside there from the
Robotic.
atmospheric friction and also heating, and also to provide aerodynamic shape for the rocket so it can goes upward without too much obstacle with the air resistance there. And usually there is like in the inner side of the payload, in the inside form of the pellet framing, usually it will have tons of like absorption and
Heaters
whatnot
and
to
thermal guides.
ensure that there is no much of the big mechanical stress and whatnot. Okay, and we have start of the first stage booster landing burn. Only one of 9 million one D being used, and it doesn't use that much. And it's of course going to land on the drone ship.
One
Here you
deployed.
can hear it, you can hear it, you can hear it. All right, there's it. Landing leg deployed and touchdown, and also main gen cut off. Finally.
Stage 2 FTS has saved.
Okay, stage 2, FTS has saved. Flight termination system no longer needed. Okay, and by this point we shall see shutdown of the second stage. Okay, we have Seco 1, second engine cut off number 1, and then by this point it will costing for quite some times before eventually it's going
Nominal
for
orbit
the
insertion.
okay nominal orbit insertion. At least on the parking orbit, it has already done its job, and the afterward it will target for the next stages and whatnot. So that's it. That's it for today. For now, it's going to be ballistic course phase flight. Okay, and thank you so much again, Specifers, for streaming this. I'm going to show you guys uh, the preview of the not actually preview. It's more like what's actually happening. So I'm going to show you the yeah. I'm going to show you something that previously I want to stream, but yeah, you get the idea. There is one. Okay, and what I need to tell you is that, of course, just to go with a little bit of, how do I say, um, just to go a little bit of continuation inside of the payload fairing. Usually there is like a shock absorber and what's on inside it. There's like padding and whatnot. It's actually to absorb that acoustic stress, any mechanical stress there and whatnot. So it's not going to destroy the payload inside there. In this case, it's Starlink. And yeah, for now, for the Starlink mission right now, it's going into the parking orbit first, followed by a few seconds of the ignition on the second engine start number 2 before before second engine cut off number 2, Seco 2, and afterward a few tens of seconds later, a few tens of minutes later, just to just to ensure the thrust residue isn't there, just to make sure there is no more pushes there as a result of the burning of the propellant. It will stay a little bit, and afterward it will deploy one by one of the star of the Starlink, in this case Starlink Group 10-46 with 29 Starlink, and then it will slowly deploy until everything will deploy, and then afterward it would start second 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 engine stage number 3 should ignite to finally ends the mission and re-enters back to Earth. And afterward, after this Seco number 3, second engine cut off number 3, of course the stage will undergo stage passivation. That's essentially to remove excess pressure, because otherwise, if it doesn't remove that excess pressure, it could cause tons of problem. For example, the most simplest thing that we can talk about is that, imagine, because of that excess pressure, it's slowly building up too much to the point that gases no longer can escape. It's like a thin sardine pack inside it, and eventually second stage will fully burst off the tank itself, and it's going to catastrophically destroy the mission and could potentially introduce another space debris. So that's why stage preservation is very important. And afterward, only then, only then it can actually properly safely re-enter back into Earth's atmosphere, destructively destroy the second stage. That's pretty typical. And usually when it re-enters back, it will circle around the Earth for quite some times, and then will re-enter back into the Earth around the Pacific Ocean, specifically the Point Nemo, where there is literally no civilization, there is no land, there is no much ship, uh, aeroplane stuff there. So that's basically where's the safest place to go, and hopefully the marine life there, all of the important uh, s- excuse me, all of the important habitat that lives around the seas, around the Earth. Hopefully they survive, and it will become nothing more than harmless space coral for them. So yeah. And I'm going to cover to you guys the Starlink 17-24. Okay, this one happens around 8 to 9 hours ago, launching from the Vandenberg Space Force Base on Slick 4E. Okay, Space Launch Complex 4 East. 4 East. So yeah, I'm going to show you here. Just give me a little bit of time. I'm going to show you. If you want to know what's a bit different with their advertising, here I will show you. Here is it. All right. So again, same link from Space Affairs, because of course, otherwise it would be hard for me to try to stream this one. So let me go with this one. Okay. Mm-hmm. Mm-hmm. 17-24. Okay, so let me show you. It should be good. Yes, I believe it shall be good, but we can increase this a little bit. Yes, sorry. Yeah, precisely. So let me show you what's the difference. And you want to know something? I actually like the launch range commentator, something like that. And you can see this is the difference. It shows like fast connectivity when you need it, where you need it, and it claims like it's available whichever place it's already have right now. For example, you can see there. And then afterwards should be another one. If you see from this also it says internet from space for aura chasers. You will see here. Okay, this one no sound, unfortunately, but this one is actually story from the from Brazil, Sao Paulo. As you can see, we cannot hear it because this is I don't know. Ooh.
People around my community, we live in remote areas, and
so here we go.
Yukon territory, we actually benefit a lot from this satellite communication.
So this is it. You can see how it was actually advertised.
The setup is so easy that anyone can understand.
And also for
Without
new
the
and
Starlink
existing
here in
viewers,
the
hello and
territory, the
welcome.
options are very
I'm
low
actually very
to
appreciate
connect.
that you actually
We
watch
have
this
only
stream,
very
even
few
though
companies
there's
that can
only one
cover
people,
in a few
but
places
it's okay.
around the north.
I've already got
Starlink
used
will be one
to
of
it
the
pretty
ones
fast.
that cover completely anywhere.
Okay, this is how it actually
changes the way
advertised.
I work every day.
It's actually different on each stream, of course.
Starlink It's one of the tools that help me to communicate in real time. So a lot of the community of Aurora chasers in the
Yeah, so this
territory
is how
can
they actually
see what's happening
advertised
with
it.
the Aurora.
Okay, afterward.
Starlink keeps connecting anywhere, in any situation.
Okay, so she'll be there. Yeah, already ended. And let me see if there's anything is super duper important. Yes, another one. How they actually also advertise here. You can see the same one, same as usual. Okay, reliable coverage. Let's go in straight to the meat and potato here. So here you go. You can see at T minus 30 seconds on this launch replay of the Falcon 9 rocket that carries Starlink Group 17-24. From this
T
one
minus
25.
15 seconds.
This one is 25 satellites on
T
board, as
minus
you can see.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff of the Falcon 9. Go SpaceX, go Starlink.
Yeah, I actually kind of like this.
Vehicle is pitching downrange.
It's like not really
M1D chamber
uh
pressure is nominal.
yeah, it's not really like super duper perfect English. It's like a centered English, but well, I actually really like it. As you can see, the launch procedure is plus minus actually the same as the launch we saw earlier for the Starlink Group 10-46, but this one actually launches from Vandenberg. And as unfortunately the launch area surrounding it, it's not looking pretty foggy there. So yeah, pretty cool time there, you
Falcon
know.
9 is supersonic.
And okay, afterward it reaches supersonic, and then it reaches to the max Q, maximum aerodynamic pressure, fully exerted on the launch vehicle, on the rocket itself.
Max Q.
Yeah, with practically peak mechanical stress there, and it need really to pass this phase, because if it doesn't, it's going to destroy the rocket itself and also even the payload on board. In this case, the satellite itself, the Starlink Group 17-24. So
MVAC chill.
So usually also I need to mention to you once again, Merlin 1D engine will actually go throttle down back to 60% by the time it reaches subsonic Mach 0.5 before it throttles back up again after passing max Q. And then you hear the call out from this replay. That one is the vacuum Merlin engines being called down to the appropriate temperature. So by the time it actually ignites, it's not going to cause uh, rocket engines melting on the second stage engine there, and also to ensure that it doesn't receive that super duper thermal slash temperature shock there. And as you can see, as it goes into space, the plumes getting bigger and bigger. In this case, these stages
Main
uh,
engine cutoff.
uh, were were finally being passed upon
Vector
the
clearance confirmed.
second stage, as you can see, after the Miko main
MVAC
engine cut
startup.
off, and then stage separation, and then second engine start number one, you can see. And just for a little bit of briefing here, because I have already mentioned
Both
this
vehicles are following nominal trajectory.
how lots of time, so I'm going to simplify what I'm going to say. You can actually refer back to the earlier on, but TLDR,
Fairing
the
separation
reason
confirmed.
the reason okay, afterward you see the fairing separation, and inside the inside the NOSCON fairing, usually it would be absorbed by internally would be absorbed by tons of like how do I say, like a cube square form, something like that, to absorb the acoustic and also mechanical stress there, to ensure that the payload inside the satellite inside the rockets itself safe. And as it going into space, obviously there's nothing to to worry about the heat, the friction, atmospheric pressure, and whatnot. So it finally can separate the uh, pilot pilot nose cone fairing there. And usually you can see why it's glowing pretty red hot glow there on the second stage engine there is because it's a complex hydrocarbon. It's mostly only only have carbon and also hydrogen linked together very complexly, very long chain. So when you burn it, it burns with tons of heat and also tons of carbon dioxide, soot, and whatnot. So that's why you can see why the color is like that when it ignites. And also because it's right now currently in this because that was currently in the space, of course, because there's literally no atmospheric pressure and also friction to hold the rocket flame. Usually the rocket flames is going to expand infinitely as long there is like how how tall is that nozzle, as long there's still nozzle at the end, as long there is still exhaust glowing red at the end of the day, it's still going to expand infinitely until there is no more nothing there. So it's expand and expand. So that's why the second stage rocket nozzle there needs to be made bigger and wider to capture this thrust efficiency lost and also to maximize the fuel propulsion potential there. So that's why. And afterward, you see it's already on the first stage or already re-enters back into Earth, and then afterward will be followed by the entry burn start there on the on the first stage booster there. First, it will start one of the 9 Merlin 1D engine, followed by another two sets pair of it, and then when it shuts down, it just do the vice versa. It's just going to reverse, and then stage one FTS is safe. It actually means the flight termination system on the first stage booster no longer needed, aka known as life basically mission ending command for the first stage engine. If for the first stage booster, if anything happens, they can uh they can destroy the rocket itself if they want, but fortunately they don't have to do it on the first stage, so it's once again being reused again. And then afterward it will spend a little bit of more time with the hypersonic speed there and whatnot, and you shall see. There's another fun fact that I need to tell you. Originally, on the grid fin itself, the grid fin used to be constructed with the carbon carbon how do I say carbon carbon composites. Okay, try imagine this is like carbon fiber, but you just make it very thick. Originally, were constructed with that, but at some point after SpaceX already looked back at it and they see tons of erosion happening as a result of the
Stage one
ap-
transonic.
uh, as the result of the hypersonic plasma venturi hit there. They decided to just change the grid frame material construction with the titanium um, alloy one instead. And then till this day they still stick with it because it's not easily eroded in the hypersonic at the hypersonic plasma speed as much as the carbon carbon composite fiber there. And then you see on the landing burn
Landing burn.
start, of course it's on the first stage. Only one of the Merlin one not only one of
Ignition
the
terminal guidance.
9 Merlin 1D engine ignites, but even then it's not many as much thrust as
Stage one landing
it
leg
should
deploy.
be. And then after that, landing leg deploy, it opens up the landing leg, and then properly throttle down, and then finally shut down of
Stage
the
one landing
first
confirmed.
stage. And then not long after that is the Seco 1, second engine cutoff number 1. This one, if I remember, the Starlink Group 17-24, this one brings around how many? Uh, if I remember, the altitude is 279 kilometers, if I remember correctly. Something like that.
Okay,
Ah, yeah.
automatic shutdown.
But The point is that that's the mission. Yeah, but that's the point. And also, just like similar to the Starlink Group 10-46, it's also going to use the same amount of trajectory, almost, but only the orbit and the orbit altitude target and also trajectory inclination just different, but it has one same destination to the low Earth orbit. And yeah, of course, just like we saw on the Starlink Group 10-46, it's going to ballistic course phase for a little bit. It means no engine will ignite on the second stage engine before ignition, before the second engine start number 2 ignite commanded, and then ignites the Merlin vacuum engine, followed by the brief ignition, and then followed by shutdown of the second stage engine there, which culminated into the second engine cut off number 2. And afterward, the upper stage will not deploy, at least on the payload portion side. It's not going to deploy anything. It's just letting all of this burn thrust residue to finally taper off, aka in other words, just let this previously burn propellant to finally subside, basically to reduce it as much as possible to the point almost nothing or little or practically nothing at all. And afterward, only then it finally deploys its satellite. And yeah, it does successfully deploy. And for now, we are still waiting for the this current Starlink Group 10-46. We are still waiting. So that's that. So yeah, thank you so much everybody for watching. I hope you enjoyed this live stream. This live stream. And also thank you so much everybody, and have a nice day. And this is my closing. I'm Daniel Suguwa, your host today for for the launch of this SpaceX's Falcon 9 Block 5 rocket, which launched from Cape Canaveral Space Force Base. Cape Canaveral Space Force Station, from the Slick 40, aka Space Launch Complex 40, which the Falcon 9 Block 5 rocket carries the Starlink Group 10-46. In this case, there is 29 satellites on board there. So yeah, it launches in the constellation form, specifically known as the Walker constellation. Not the best kind of efficient way of putting satellites. If you like to play lower amount of satellites, but you need to cover more, technically you can also use another one. If I remember, another technique is the Flower constellation, but that one you cannot just plan using just like you try to plan with calculator and whatnot. No. That one you need to use you need to play around with the computer algorithms in order to do that planning for you. I mean, not impossible. I think maybe we have this today, or maybe there's neither, because the application is quite limited so far. But well, you see, that's the future. Nothing is impossible. So yeah, thank you everybody for watching, and take care. Have a nice day. Goodbye, and yeah, that's all. And see you on the next live stream. Bye bye.